Have you ever walked into a cafe and found a really long queue? Today, we are going to show how waiting and queuing theory works in a real cafe.
That fast, I didn't even have time to check my phone.
When customer arrivals are low and service is fast, waiting time is short.
Bang bang games until you lose control. Bang bang games until you lose control.
If this take any longer, I might be late for class.
Is this the line for coffee or for concert tickets?
Meanwhile, one hour later, 2 hours later, 3 hours later.
During peak hours, when many customers arrive at the same time, the waiting time increases.
Excuse me? Are you the manager?
Yes, I am.
I would like to file a complaint about the waiting line. It's way too long.
Oh, I see. Thank you very much for telling me. In that case, I'll be considering to add another one more count.
Yeah, that would really fix the problem.
Thank you very much for telling me.
The location of Cafe Dim is at number 33, Persiaran Jejawi Utara, Kompleks Perniagaan Jejawi, 02600 Arang Polis. The operating time of Cafe Dim is from 8 AM until 11 PM. We do the observation is from 3 PM until 5 PM. The number of server is only one server. Next, characteristic of the queuing. For arrival characteristics, we have size of the calling population, pattern of arrivals, and behavior of the arrivals. Size of the calling population for Cafe Dim is unlimited, which is essentially infinite. The potential number of Cafe Dim customers is so large and unpredictable. Patterns of arrivals at Cafe Dim is Poisson distribution, where 10 customers per hour. For behavior of the arrivals is impatient. The customers show impatient and dissatisfaction due to long waiting time, but does not renege as they remain in the queue.
Next is waiting line characteristic. The length of a line for this system is unlimited since there is no limit to the number of customers that can wait in the queue even the line becomes very long. Next is queue discipline. For this system, it's applied for first in, first out, or also known as FIFO, because the Cafe Dim customer that first arrived at the counter is the first one that will be served. Configuration of the queuing. So the number of channels or the servers for this system is a single channel system or only one service, while the number of waiting lines is single line, where the customer will only enter a single phase system.
Next, the assumption for the pattern of the service time follows the exponential distribution in which the mu is equals to 12 customers per hour, which means the server took 5 minutes per customer on average in an hour. Next, for the basic queuing system configurations, we can see that this cafe has single server, single line, and single phase system. Based on the diagram, the customer will arrive and join one queue and wait for their turn until they reach the counter, where there's one server taking orders and payments at the service facility. Once the order is prepared, customer will wait to be served.
For the calculation part, the server S equal to 1 since the cafe only has one counter. The arrival rate lambda equal to 10 customer per hour and the service rate mu equal to 12 customer per hour. So first we calculate the average time a customer spend in the system for S equal to 1 using W equal to 1 over mu minus lambda. We get 0.5 hours. As we know, the service cost is equal to 9 ringgit per hour and the waiting cost equal to 3 ringgit per hour. So we substitute all the information in the total cost formula, we get 24 ringgit per hour. Now, let's calculate the utilization factor for the system for S equal to 2 using rho equal to lambda over S times mu. Get 0.417. After that, we calculate the probability that there are 0 customer in the system using P0 formula. So the P0 formula is a little bit too long, and then we get 0.412.
Next, to calculate the average number of customers in a queue, we follow the formula LQ equals to P multiplied by lambda over mu to the power of S multiplied by P0 divided by S factorial multiplied by 1 minus P to the power of 2. Once we substitute all the values obtained from this problem, we get 0.176 customers. Next, to find the average number of customers in the system, we use the formula L equals to LQ plus lambda over mu. In this case, we just got our LQ value, so we substitute it in. Hence, we will get 1.009 customers. Next, to find the average time a customer spends in the system, we use the formula W equals to L divided by lambda. In this case, our average time a customer spends in the system is 0.1009 hours. Lastly, we calculate the total cost. To find the total cost, we must divide CS with S, add it together with lambda times W times CW. When we substitute all these values, we get 21 ringgit and 3 cents per hour.
Lastly, conclusion. To conclude everything, it is worthwhile to add one more counter at the cafe since the total cost for 2 servers is lower than total cost for 1 server.
When you say those things, I don't think you realize what they mean to me. Messing with my head, I'm going ADD. Keep the memories, cause I don't wanna be just friends. Now I'm on my own, scrolling through the messages.
This is how waiting and queuing theory applies to our daily life. It helps businesses reduce waiting time and improve customer satisfaction.
Thank you everyone for watching. I hope what we just explained just now will help you to have more understanding for this topic.
Bye!